For decades, telecom networks have been the lifeline of our world. Always there, always reliable. But now, we are at the tipping point for the future of communication. Telcos are evolving into something more. AI-powered grids that don't just connect. They think, adapt, and solve. Customer experiences and network operations are being reimagined with AI agents. AI factories are accelerating research, redefining innovation, and unlocking new possibilities for industries and nations. What were once simple relays are now AI powerhouses. Cell towers transforming signals into intelligence for billions. 5G and 6G are being designed, simulated, and trained with AI, making every connection smarter, every interaction more seamless. This isn't just an upgrade, it's a renaissance. Telcos are no longer just the backbone, they're powering what's next in physical AI, robotics, and beyond. AI is defining our future, and the future moves on telecom networks. The only question is, how far can we go together?
Welcome, everybody, and thank you for coming. As Emeka said, 8 o'clock in the morning is tough for some of us, but pleased you're here, and hopefully you'll be learn something new over the next 50 minutes or so. But knowing many of you in the audience already, I know that this is something that you come to expect from NVIDIA already, which is innovation coming together with telecommunications. Telecommunications touches the lives of billions of people around the world on a daily basis. There's not too many industries that have the impact that this industry has on the world. We all carry computers in our pockets. In fact, we call them smartphones now. And as we carry those smartphones around, we expect that every generation we're going to have more technology in our pockets. We're going to have more accessibility to that technology. There has never been a better time for AI to be affecting how do we have access to that technology, what kind of technology we can have access to, and the business models around the availability of that technology. NVIDIA started on our telecom journey a few years ago. We're already working with about 150 telcos around the world. 90% of the top 50 telcos have started already on their AI journey. Let me break down some of the areas that we're working with telcos around the world. We're going to talk today about 3 main areas of engagement of AI with telcos and the telecom ecosystem around the world, and also how that ecosystem is growing through the engagement with NVIDIA. Firstly, we're going to talk about how AI is improving operations, improving the experience, but very importantly also improving the productivity of telcos. Secondly, we're going to talk about something that hasn't probably been talked about for a while in the telecom industry: new revenue opportunities. How do we grow the top line? Not just by 1 or 2% every year, but by multiple percents every year. And then we're also going to talk about the network itself, the radio access network, and the transformation that has started already, and how we see the future of the radio access network together with many of our partners that are moving towards that future. So we've heard a lot this week about the journey of AI, large language models, the training of large language models, the ability to then take retrieval augmented generation and use local data to fine-tune those models. This year, we've started to see agentic AI, but we're just at the start of agentic AI. Building agents sounds simple. It's actually very difficult. Initially, the first task that has been taken on by telcos in this agentic journey is to improve that first thing I talked about, which is customer experience, the customer engagement, the speed and productivity of resolution of customer issues, the engagement that you have with your customers as telcos, your millions of customers. That agentic flow is rapidly moving into now agents for operations, where agents will work together, teams of agents will work together to solve problems. The agents need data to enable that to happen. And that data is the data of the network. It's different from voice and video and text. It's network data. It's configuration files and logs and sound data, it's RF data. It's very different and it's very unique, but it can also be trained in a large telco model. It's the language of the network. NVIDIA, using our NeMo frameworks, are enabling this agentic flows to be built. And what we've seen now, which I'm going to show you, is how agents can actually organize themselves, manage themselves to make decisions within the network. Decisions that would have normally taken days can now be done in minutes. This is transformational, as I said, in that journey of AI. Let me show you one example. SoftBank, a great partner of ours, has announced now a large telco model optimized with NVIDIA Inference Microservice, the NIMs that you've heard so much about. Let me show you how SoftBank has now been able to take something that would normally take days and move that into minutes, which is the planning for a baseball game within Japan.
Hi. A major baseball game will be held tomorrow at the Central Stadium in Tokyo. How should I prepare my network for the expected traffic?
Sure. Let me first make a prediction of the traffic. We expect twice as much traffic demand inside the stadium. Let me find out how we can handle it. I suggest moving some users to adjacent cells. Here's an example config. Let me now simulate the changes. Config updated, users offloaded to adjacent cells. Now you have 30% more throughput per user, as per my simulated results.
Great. Can you schedule these changes for 2 a.m.?
Sure, done.
Let me show you another example, how one of our other partners, Amdocs, has been able to build an agent to handle resolution and tickets. This actually is exactly how NVIDIA frameworks can be used by one of our great partners, Amdocs, in being able to build these agents.
I see there's a major issue. Please propose a few options to deal with the situation.
I've identified 3 potential resolutions and can simulate them using a network digital twin. 1. Offload traffic to a backup link. 2. Limit video traffic up to 50% of the available bandwidth. 3. Increase temporarily the bandwidth allocation on the primary link. How would you like to proceed?
Simulate option 1.
Offloading traffic will successfully mitigate the latency spike and prevent service degradation in the area. However, the simulation indicates the backup link, while capable, will operate at 70% capacity. This reduces our redundancy margin and could impact disaster recovery capabilities should a secondary issue arise. Would you like to proceed with this option?
Yes, please implement this option. Thanks.
As you can see, the world of network operations is about to be heavily influenced and changed and transformed by agentic flows. We're just starting on that journey, and some of our partners are already starting to deploy these capabilities. Let me turn attention now to another one of these growth drivers. I talked about, remember, top-line growth as well. This is a very important journey that many of our partners have already started on. This, as you have heard, is over the course of this week, and in Jensen's keynote, is the concept of AI factories. This is AI infrastructure to generate revenue. I'm going to talk a little bit of why this reset of traditional cloud computing is so applicable to the telco industry. As we know, cloud computing has not been any stranger to telcos. Many telcos have already had clouds of traditional general purpose cloud computing. That really wasn't a revenue generator for them. However, turning those facilities, which is the real estate, the access to power, as well as, of course, their customer distribution and customer connectivity, now can enable that installation of AI factory to be generating revenue. So far, 15 telcos around the world have announced that they are building these AI factories as part of the NVIDIA Cloud Partner Program. Many are serving a sovereign agenda, meaning that data is sovereign, needs to stay within the region. Data that is important, like healthcare or education or research that needs to happen in the region, promoting research within the region, and of course, leveraging the reach that telcos have within the region. As part of the NCP, the NVIDIA Cloud Partner Program, telcos also get access to reference architectures, the software suite that you saw, the NVIDIA AI Enterprise Software Suite that sits on top of that infrastructure. And as many of you are experiencing here this week, an ecosystem of partners that you can learn best practices from. We also have 27,000 companies in our Inception program. Let me show you just a few examples, or one example of how one telco in Indonesia, IOH, has already deployed their infrastructure, and one of their customers, GoTo, which is an enterprise customer, has built a voice assistant to their enterprise using a large language model trained on Bahasa Indonesia language. Also, there's another company, Telenor, that's just signed recently as an NCP that's delivering technology to startups in their region and access to GPU as a service. And then Iliad, which is also working with innovation and startups. So let me show you the IOH example.
Dira, pesenin gue ride ke kantor ya. Dira, pesan GoFood yang kemarin dong. Dira, isin pulsa Indo 1 ya. Dira, cek pengeluaran aku dong.
The Sahabat AI service is built upon the very important large language model that was trained. Now, this week, we're very pleased to announce that another telco is joining the NVIDIA Cloud Partner Program. TELUS. TELUS made an announcement this week that they are building the first North American service provider. They are the first North American service provider to become an NVIDIA Cloud Partner Program. We're very pleased to welcome them to the NVIDIA Cloud Partner Program and all the benefits that they will be able to provide to their region as well in Canada. Canada, as you may well know and may have read, has made AI a national priority. And who better than TELUS to be able to service that national priority to Canada? So thank you, TELUS, for being able to bring this capability to Canada through the NVIDIA Cloud Partner Program. You heard this week from Jensen about the 3 scaling laws. Many of us have focused initially on our AI journeys on that first scaling law, which has actually been around for quite a while, a few years, which is the ability to train and build those large language models. As we move through that second scaling law, which is the fine-tuning and the use of reasoning, we also see a demand on infrastructure and different software stacks, and that demand is growing. The third scaling law, the test time scaling, is now starting to become obvious that is going to be the inference wave. People actually using, and there's going to be reasoning in that as well. There's going to be chain of thought in that as well. So we need infrastructure to be able to service all of those capabilities. All 3 are growth drivers for telcos, and telcos can play a very unique and important role. What's called the AI grid. The AI grid can service all 3 of those scaling laws. Of course, the central AI factory in the hundreds around the world. Now, the AI inferencing that can happen in distributed locations to enable accessibility to that AI from the phones or from whatever devices. So that's going to be in the order of millions of sites of infrastructure. And then, of course, last but not least, the consumption. Many different endpoints. So I'm going to talk a little bit now about how do we connect those endpoints. We all know that billions of people around the world, as I said, are connecting to the network. Voice, video, data. Going forward, there's going to be AI traffic. AI traffic is going to connect to hundreds of billions of things. How can that be possible? How can that happen in an industry that has had to deliver more and more technology? Of course, we have the AI agents, the NIMs, that can be deployed in the distributed locations. And I'm starting to tell you the story of how that happens now. The NVIDIA inference microservices, lightweight models that carry the large language model data, have the security, whether it be for video language models, or it's automatic speech recognition, or language translation. All of those we will want on these multiple devices. Let me just show you the video search and summarization example here. Perhaps one of the biggest growth drivers for the network and perhaps one of the biggest traffic drivers for the network. Instant video search and summarization at the edge. Here you can see how instantly inferencing needs to happen as real-time events are flagged and recorded, not for viewing later, but instantly at that time. Now let's think about consumers, tens or thousands of people all wanting to connect to the network at the same time, using AI agents on the phone. Those AI agents, a lot of that computational reasoning needs to happen at a location nearby. It can't happen on the phone. We're already seeing phones that are starting to become agentic phones. And of course, we're already seeing the first deployment of robo-taxis. That's going to increase. Now, of course, you're not going to make decisions in the robo-taxi of do I turn left or do I turn right by a network nearby. What we're going to see is certain functions can be offloaded to the network. Certain functions can be decided in the vehicle. So intelligently connecting intelligence is really critical on how do we orchestrate this infrastructure. And on that point, there's been a lot of talk about the reason for the edge. For many years, we've talked about the edge as something unique that is different, and why should we have it? And often latency is brought up. But one of the challenges of latency is not the connectivity, which is milliseconds, but it's actually the compute latency. It's how do you organize the compute, which can take seconds, to service that service level agreement with the end application. That is critical. Physical AI, you need less than a second. Conversational AI, to make that conversational with barge in and realistic and make it pleasing to the user, is less than 2 seconds. Video search, you saw earlier, probably less than 6 seconds. And some reasoning, you can let that reason for a while if you have a task that can take minutes. What NVIDIA has been doing is we've been working on how do you orchestrate the computation within the architecture as well. And that is one of the reasons for the edge. But also, if you think about data upload to the cloud and the cost of data upload, that's another reason for the edge. If you think about data gravity, data proximity, data sovereignty. Maybe you have a warehouse or a hospital where you don't want that data going to the cloud. That's another reason for the edge. Bring these things together and we're seeing a renaissance for distributed compute architecture. AI factories that need to be distributed. Compute latency, agentic AI optimized and embedded techniques within the compute architecture. A deterministic experience, no longer leave it to best efforts implementation. And telcos are ideally placed for determinism because timing in telco networks is and has to be deterministic. Of course, total cost of ownership on how do you provide infrastructure to make that infrastructure pay dividends. And as I mentioned, data localization. Privacy of data is becoming very important to enterprises, to research organizations, and of course to countries. The traditional telco network is serviced by single-purpose equipment today. A lot of CapEx goes into single-purpose equipment, and that's great equipment for that application. It doesn't, because we're provisioning for peak use, it's not always utilized. On average, 30% utilization of that single-purpose network. what we have been working with many of our partners in the industry is the concept that now should be no stranger to anybody in this audience, AI RAN. This is the fusion of AI and the radio access network on a single homogeneous infrastructure. Of course, RAN has to be software defined. Saying that is easy, making that software defined implementation high performant, high perf per watt is actually been very difficult. And NVIDIA's been on this journey now for over 7 years. But AI RAN is here. Let me break down AI RAN for a second. There are 2 components here, but you can actually think of 3 components. There is AI for RAN, which I haven't touched on yet. That is where AI is going to improve the spectral efficiency, the power efficiency, the operational efficiency of the radio access network. There is AI and RAN. You can break that down into 2 parts. AI running together on the homogeneous infrastructure, together with the RAN, and AI being delivered on the radio access network, with the radio access network as a transport media. And you saw a little bit of that potentially on the previous slides on how you can deliver the software level agreements. Our partner SoftBank has been able to demonstrate some of the benefits already of AI RAN in their test setup in field setup, actually, in just outside of Tokyo. There are monetization benefits, return on investments, return on invested capital benefits, utilization benefits, energy efficiency, many benefits that are already proven with this AI RAN. Now, how is NVIDIA providing the right tools and technology to enable AI RAN? So the AI RAN reference architecture starts off with the NVIDIA Aerial RAN computer, which is the GH series of infrastructure, Grace Hopper series of infrastructure, together with then, you think about this as 2 software workloads that run on top of that. There's the RAN stack, layer 1, which is accelerated in the GPU, and then other parts of layer 2 potentially, as I'm going to come on to, that can also take advantage of the GPU in the system. There's also network functions that can be delivered now that we have an accelerated compute architecture, and then orchestration as well. The AI RAN Alliance, a group of 10 companies that came together with this vision about 1 year ago, has now grown to over 75 members in just 1 year. At Mobile World Congress a couple of weeks ago, 10 demos were shown, by the AI RAN Alliance, 9 of which use that reference architecture I showed you earlier. T-Mobile, together with our partners Ericsson and Nokia, we're working together on an AI RAN innovation center with T-Mobile. New partnerships that are leveraging AI aerial as well were demoed and showed at Mobile World Congress. SoftBank has their product ATRAS, which they announced last year, which is a full stack, full solution RAN product offering using NVIDIA AI aerial. And new network functions that are taking advantage of not just the GPU in the system, but also the blue field. So UPF, for example, 5G core, for example, other network functions that can be accelerated at the same time on the same reference architecture. And the most recent telco that has announced they are moving to an AI RAN distributed implementation, which is Indosat Ooredoo Hutchison in Indonesia. Going forward, We see the possibility now, very clearly, based upon the demos that have happened already, that we see AI is going to play a very important role in improving the spectral efficiency and performance of the radio access network. One of our partners, DeepSig, has been able to show, by using a pilotless implementation of a layer 1, a neural network layer 1, already getting 70% throughput gain. And then Fujitsu and SoftBank together showed a 50% uplink performance. As Jensen said on the release that we did on, which I'm going to talk about, next generation networks will be revolutionary and will have unprecedented opportunity to ensure AI is woven in from the start. We were pleased to announce at Jensen's keynote that NVIDIA is working together with like-minded companies, T-Mobile, MITRE, Cisco, the ORAN development company, part of Cerebus, and Booz Allen, on that vision and realization of that vision. We are working on research, which is AI native, to enable us to deliver blueprints and capabilities as a minimum viable product and a blueprint for deployment into 6G. But also that minimum viable product has to be carrier grade, has to be capable, has to have AI infused in the hardware and software. And this, we feel, is such an important mission to take advantage of the 6G standards starting to get formed and the importance of AI coming into a deployable system, that we've brought these companies together. The NVIDIA research portfolio has been chosen by innovators globally. A year ago at this conference, we announced our 6G developer program. Our 6G developer program includes tools, which I'm going to come on to how some of them are being, new tools are being developed. We now have over 2,000 members of our 6G developer program. Some of those tools, which I'll talk about, are now gaining such notoriety in the industry as being the de facto standards for certain functions. But think of, as you saw in that video, this is a 3-computer system: training, simulating, and deployment. The first tools I'd like to announce is Siona 1.0. Siona link level, differentiable, layer 1 simulator has now been accelerated with accelerated ray tracing. This has 150,000 downloads since the release of Siona. Also, to go with Siona is the Siona Research Kit, which is the hardware which you can now run those algorithms on. A tremendous resource tool using the Jetson GPU from NVIDIA. Also, we are now announcing the new capability for Aerial Omniverse Digital Twin. Aerial Omniverse Digital Twin is moving to DGX Cloud. Aerial Omniverse Digital Twin available anywhere: PCs, workstations, DGX Cloud, AWS, Microsoft Azure. Putting these research tools into the hands of those that need it to do full physics, real-time simulations. As well as that, we're announcing our aerial commercial testbed on GH200, already in the hands of many, which uses an open air interface stack, OAI stack. Already we have partners, Sterling, the open air interface, Supermicro, and radio partners, Lighton and WNC. Let me show you how this works. So firstly, traditional radio access networks have always required a very manual process for design. Now using Aerial Omniverse Digital Twin, physically accurate scenes can be developed that can comprehend elements important to the RF propagation. As you can see here, this is a this is actually downtown Berlin. It includes all the elements. But how do you build that up? You start off with a number of UEs, user equipment, moving around in a neighborhood. And you can build the plan of the neighborhood in 2D. Once you have this scenario built in 2D, you now can start building 3D. Put buildings in, material properties of buildings, foliage can start to come in. All of these affect the RF propagation and the ability for base stations to deliver and receive signals throughout that environment. Then we can also start to see that they're ray-traced beams, which it represents the real-time with EM solver RF propagation in the real world. What we were able to do using this aerial omniverse digital twin is now start to see how we could use, say, a neural network in layer 1 compared to the traditional channel estimation. So using a neural network, which is AI in layer 1 for channel estimation, we were able to simulate and also deploy in a real-world environment. And you can see about a 40% improvement in channel estimation by using that AI in layer 1. Once optimized, the simulation can be sent to base stations, and you can see things like cell edge coverage in the real world. This is an unprecedented capability that we're starting to see now real-world users will be able to take advantage of as we're planning networks in a simulated environment and then deploying. Our NVIDIA AI aerial ecosystem is growing. I'd like to thank all of our partners that are moving with us on this journey that is transforming the networks using AI RAN. So the telco AI renaissance, I hope you agree with me now, has really started. Where you start that journey depends on you. However, start the journey now. Make sure that you're going to take advantage of these transformations. We see a tremendous journey ahead, and it's a very, very exciting future for us. Thank you very much.